Hey everyone, so today we're going to be working on the Unit 5 review. This is a we do, I do setup. We do, you do setup. So this video specifically will cover the we do part of the review. This is going to show you how to work through these problems. There is a corresponding assignment that relates directly to the I do portion over here in Schoology. So once we get through the notes video, you can work on these problems in Schoology. Alright, so let's get started. So in this first problem, we're told that BC and DE are parallel, okay? So we want to find which of the following corresponding proportions is true. Mark all that apply. So here we're going to be looking at each option, okay? We have to look at each segment and compare how the proportions work. Okay, so we're going to work through this first one by writing, and then we'll just do the other parts by hand or verbally. Okay, so the first part, we're talking about AD, which is going to be small, the small portion, over AB, which is a big portion, so small over big, equals AE, this corresponding part on the other side of our small, over AC, big. Okay, so what we're looking at is these relationships between the segments. So we have small over big segment equals small over big segment. In this situation, A would in fact be an accurate proportion. Okay, so let's check the rest of them. We have AE over AC, so small over big, equals DE over BC. Small segment, think small triangle, over BC, this would be the base of our big. So small over big on both. That means B is also a correct proportion. Okay. Looking at this example, C, we have DE, which would be the small part of our triangle, over BC, okay, so that's the big base, small over big, equals AE, which would be the small part of our triangle, over EC. Okay, so here we actually are just only looking at a portion of the larger triangle. So here we technically have small over big, okay, because DE over BC equals AE, which is small, over EC, which is actually a small portion as well. Okay, so this one, B is not, or C is not a adequate proportion. Okay, and then our last example, AC, so let's erase this real quick. We got a lot going on. Here we go. So AC, there we go, AC, big over AB, big, okay, so big side length over big side length equals AD over AE. Okay, so this one, we need to look at the order. We have AC over AB, so right over left, okay, equals AD left over AE, right. So this one, they are technically not corresponding because we have right over left equals left over right. In order for these to be corresponding, they would need to be flipped. So D is not an adequate proportion either. So for number one, we have A and B. Okay. Moving on, we have a cat stuck in a tree. All right, meow. The firefighters are trying to rescue it. Based on the figure, if a firefighter climbs to the top of the ladder, so if the firefighter is going to go up here, how far away is the cat? Okay, so X right here is notating how far it is from the top of the ladder to the tree. So let's set up our proportions. Okay, we're going to say that the base down here, the base of our tree 40 over the length of the ladder 46 is going to equal the top portion of our tree 30 over X, okay, the top half of our ladder. So now that we have our proportions set up, I'm going to say this ratio right here can actually reduce. So to make my life a little bit easier, I'm going to find that common denominator, or common factor, not denominator, the factor that can be pulled out. So I know that 40 can be divided by 2 for sure. I think that's pretty much it. So I'm going to reduce my ratio so that I have easier numbers to work with. So we're going to get 20 over 23. That's if we divide by 2. Okay, so that's going to equal 30 over x. Now I can solve. So once we're here, we cross multiply. So we get 20x equals 23 times 30, which is 690. Okay, then when we divide by 20, we're going to get a total of x equaling 34.5. Okay, so if our firefighter is right here at the top of the ladder, then we know that the cat is still an extra 34.5 feet away from him, okay? Or her, because women can be firefighters too. So, in the next problem, if ABC is similar to DEF, then we want to find the area of a triangle ABC. All right, we're given that DEF is a total of 60 square feet, okay? Thinking back to what we know about proportions and area, we know that the area of one, so we'll just say the area of A over the area of another triangle is equal to the scale factor, we'll call that K squared. Okay, so in order to figure out the area for our second triangle, first we need to figure out our scale factor. Okay, so to find the scale factor, remember that's just how we are changing from one image to the next. So I'm going to say my scale factor would be 12 over 8. Okay, so the direction isn't important as long as you keep it the same throughout. Okay. So 12 over 8 would be a scale factor of 3 over 2. Okay, so this is my K value. So now I'm going to say, all right, I have my area of my large, okay, which is going to be my blue. So area of A over the area of my B, or my small triangle. That's going to be equal to my scale factor, 3/2 squared. Okay, so now we plug in the information we know. The area of A is what we're looking for, so that's our missing value. B is 60 square feet, and that's going to be equal to 3/2 squared, which comes out to be 9/4. Okay, because remember, when you have a fraction squared, you square your top. 3 squared is 9. Square your bottom. 2 squared is 4. Now we have our ratio, so we will be able to solve this proportion and get that x value. Okay, so cross multiply, we're going to get 4x equals 540. Divide both sides by 4, so we know that x, or our area of triangle ABC, will be a total of 135. Alrighty, so moving on, now we're asked to find the scale factor between two rectangles and the perimeter of each polygon. Okay, so let's highlight what we need to do so that we can follow our steps. So scale factor of ABCD to PQRS, this order is important. Okay, so that's going to be from our small rectangle to our large. And then last, we need to find the perimeter of each polygon. We have 2 polygons, so we need to find 2 perimeters. So getting started with our scale factor, remember your scale factor is the ratio of corresponding sides. Okay, so I'm going to use 20 and 25. So the scale factor would be 20 over 25. When we reduce that, we're going to have a total of 4/5 for our scale factor. Okay, so that's step 1. Done. Okay, now perimeter of each polygon. So we need to look at our 2 polygons, or our 2 rectangles, and say which one gives me the most information. So here we have 20, which are both congruent, and then here is 14, these are both congruent. This, we're only given 25, so we can't find the perimeter just yet. So I want to start on the left. I know that these congruency marks mean my side lengths match the congruencies. Okay, so the perimeter of ABCD is going to be the sum of all the sides. So 20 plus 20 plus 14 plus 14, or you can write it as 2 times 20 plus 2 times 14. Whichever way helps you visualize it easier. Okay, so our perimeter here is going to be a total of 68. Okay, so our perimeter of the small rectangle is 68. Okay, now we need to figure out the perimeter of our large rectangle. Let's call this x. Thinking back to earlier parts of this unit, we learned that the perimeters, the ratio of your perimeters, so we could say perimeter A over perimeter P is equal to the ratio of the scale factor, in this case 4/5. So again, the ratio of your perimeters is equal to the ratio of your scale factor, all right? They are proportional. So let's fill in the information we have. We know the perimeter of ABCD is 68. We are looking for the perimeter of PQRS, and we know that is equal to our scale factor, 4/5. Okay? So let's go ahead and cross multiply, solve this out. We get 4x equals 340. Right? When we divide this by 4, x is a total of 85. So our perimeter of PQRS is going to be 85 units. Okay? All right. So here, looking at number 5, we want to find the value of x. So we have here a triangle. We're told that these two segments are parallel lines. All right, we know that by the little triangles that they give us. Okay, so to find the value of x, we need to set up our proportion. Okay, so we can say 20 over x, so left side of our triangle, is going to be equal to the right side of our triangle, 18 over 9. Notice when I'm setting up my proportion, the corresponding parts, so top left and top right, line up. Bottom left, bottom right, line up. Okay? I can see that 18 over 9, we can actually reduce this. Okay, so we'll have 20 over x equals 2 over 1 because 18 is divisible by 9. So knowing this, I can cross multiply. I get 2x equals 20. Okay, and then dividing by 2, x will be a value of 10. So one quick thing I wanted to mention to you guys, remember the scale factor is the ratio of change in between your images. Okay, so here we have a ratio or a scale factor from 18 to 9, right here, which reduces to 2 over 1, right? So it's changing by 2. It's getting smaller 2 times, okay? So if you think about that, if you see that this is divisible by 2, since these are proportional, 20 divided by 2 should give you your x unit. What do you know? Just something to think about, a little connection you can make. Okay, so moving on, we have two similar rectangles having a scale factor of 5 to 6. Okay, the perimeter of the larger rectangle is 120 square meters, and we need to find the perimeter of the smaller rectangle measured in meters. Okay, so thinking about scale factors, order is important. Okay, so order for our scale factor, 5 to 6. Since your smaller number is first, that is in relation to your small rectangle. Okay, so if we're thinking about our scale factor and how to set up our ratio, we need to remember that we need to go from small rectangle to large rectangle. Okay, I personally am a visual person, so if you can set up your proportion without looking at the picture, awesome. If not, draw a picture. Okay, so the larger rectangle right here, again, I'm writing it on the right side because my scale factor 6, the large rectangle comes last. The large rectangle is 120 square meters. It should be just meters though because we're looking at perimeter. Okay, so 120 meters. And then we have to find the perimeter of the smaller rectangle, right, x. So thinking back to number 4, the ratio of our perimeters is going to be equal to the ratio of our scale factor. Okay, so I can say that x over 120, again, I'm going in order according to my scale factor, equals 5/6. Okay, once we are here, we need to cross multiply. So I have 6x equals 600. Okay, and then when we divide both sides by 6, x will equal a total of 100 meters. Okay, so the perimeter of our small rectangle is 100. Okay, so if I was to plug that back into my ratio, I could say 100 over 120 equals 5/6. Is that true? Well, 100 divided by 20 is 5. 120 divided by 20 is 6. So we did that right. Okay, almost done. Okay, so determine which of the following triangles are similar. So similarity, different types of theorems. We had 3 of them we learned about. We had angle, angle, side, angle, side, and side, side, side. Angle, angle was when we had 2 congruent angles. Side, angle, side is 2 proportional sides and a congruent angle in between. Okay, and then side, side, side is 3 proportional sides. So, looking at our triangles, we need to determine between option A and B which ones are similar. Okay, so look at the information they give you. We have 2 sides and an angle that's included. 2 sides and an angle that's included. So I want to test out side, angle, side first. Okay, so if I have side, angle, side, I need to know that my sides are proportional. So we can say 18 over 12 equals, all right, when we reduce that, we have a total of 3 halves. Okay, and then comparing our other sides, 24 and 16, we also have a ratio of 3 halves. So since our 2 ratios are 3 halves and our angles that are included are congruent, A is proportional. Similar. The triangles are similar. Okay. Now B, I have 2 sets of sides. Okay, so let's compare the measurements. Are they the same scale factor, the same ratio? Okay, so I'm going to take my base numbers first, 8 over 12. All right, that's going to reduce to 2/3. And then we need to take 10 and 5. If 12 here is the base of my big triangle, think of these in the terms of triangles. Okay, so 12 would be the base of our big triangle. Okay, then we need to take the full side length of our big triangle, which would be right here, 10 and 5. Okay, so let's say base 12 over the side length, 10 plus 5. 10 plus 5 is 15. When we reduce that, we have 4/3. Okay, so look at your 2 numbers. 2/3 and 4/3. Do they match? Not similar. Okay, in order to be similar, those ratios, those scale factors have to be the same. Okay, number 8. Find the polygon similar to ABCD. So first, start off looking at your image. Okay, so we have this rectangle looking shape. Okay, we have 2 corners that are marked congruent, and then a third that is another set of congruency. Okay, we have 4 and 12 are our side lengths. So let's compare. This shape, okay, it looks more slanted, but look at the angles. There are no congruency marks, so that's not going to be similar. Okay, the second option, we have marks of congruency. Okay, we have another mark of congruency and side lengths. So let's test out those side lengths in comparison to our initial image. Okay, so I'm going to say big over small, so 4 over 2 equals a scale factor of 2 over 1, which is just 2. So this side here, 4 to 2, we're changing by a ratio of 2. Then when we're comparing 12 over 6, we have a ratio of 2 as well. So these two have proportional sides, okay, congruent angles. This is a very, very strong possible. This one's definitely similar, okay? And then let's just check the other answers. So down here we're marked with a 90-degree angle. This angle, we are not told there are any 90 degrees whatsoever, so we know this cannot work. And then the last one, we have a set of congruence angles. Okay, so two sets of congruency, but remember the first one has this mark of congruency up here, and this one does not. Okay, then if you were to set up your ratio of 4 over 8, you would get 1/2. And then comparing your other side, 12 over 8, that's actually 3/2. So this is not a similar polygon either. Okay? And last but not least, the most recent topic we covered. Okay, so here we have two medians. Okay, so our medians here. We're given two triangles and we need to find the value of x. We learned that this ratio of the special segments is going to be proportional to the corresponding sides. Okay, so we can say that 10 over x is going to be equal to 16 over 9. Right, once we're here, we cross multiply. 16x equals 90, and that's going to reduce to a total of x equaling 5.625. Alright, so go ahead, start working on the I do portion in your Schoology assessment. Let me know if you guys have any questions. Bye.